Okay, greetings dear friends, welcome back to my YouTube channel. For those who are coming for the first time, make sure you subscribe and follow the previous videos, because in this explanation we'll be considering the previous videos. So today we're going to see something very new and something very interesting. So to start, I'll just show you the simulation so that you have an idea of what's actually going to happen here. So as you get it already, today we're going to look at interrupt part 2. Last time we looked at interrupt part 1 already. So in our interrupt part 2 right now, a 7-segment display will be displayed a number, right? Yeah, it will be displaying a number, and while it is displaying the number, it will be interrupted to display different other numbers. So let's simulate it and see it together. So like you can see, the 7-segment is displaying the number 6. Yeah, though it does not resemble the number 6, you know. So our interrupt switch right now is connected to our interrupt pin, that's RB0. So once the interrupt is activated, you can see right now it's counting 8, 0, 2, 4, 6. So basically that's the interrupt routine we are going to be dealing with. So let's get immediately to the coding part. That's usually the part we get to this step. So after the coding, we're going to explain surely the circuit part very well. So the coding part already, I wrote the codes already. Yeah, since they are very lengthy, so it'll be very easy to explain and the video will be very short. So make sure you remain on track as we go with the video. So as we have been seeing in our previous video, here is already to precise to the assemblage of the CPU you are using, and to include the pseudo instructions of our CPU. And here right now you are originating from memory location 0 by 0. Once you are originating from memory location 0 by 0, we proceed with this instruction here. This instruction here right now, as you can see, it moves the value 75H to our general purpose registers. Normally general purpose registers come with the value FFH, but right now we're going to overwrite the value to obtain a delay of 0.5 seconds. That's also something special about our coding of today, or our simulation of today, because the numbers which are counting in the range of 0.5 seconds. If you took time to notice that, that's the reason why we are overwriting the value in our general purpose register. Here right now we're initializing our constants. We've been seeing all of these constants, count 1, port B and trace B. The only stranger here is int con register, in which we saw in our previous video, so it should be something new. So this int con register is a special function register which has memory location 0BH. In our peak, that's at bank 0, then at bank 1 it has memory location 8BH. so you can choose any of them, but in this video I choose 0BH, as you can see. So the next line right now tells us what it tells the code, the peak to go to start, whereby in our start right now, basically in our start we're setting our port as in trace B should be output, and the first pin, that's at RB0, should be input, and we saw already that because a switch was connected to it. And the next part right now, as you can see, this move LW 90H. This 90H, if you put in binary, that will be 10010004 times. So the first one indicates that we are activating a global interrupt enable. That's the global interrupt enable is activated. And after that right now, the next one who follows is an interrupt enable. So this will permit us to trigger an interrupt, and once the interrupt is being triggered, the PIC microcontroller is going to take it into consideration. Else, if this part of the code is not written, it's going to ignore it without any hesitation. And the next part right now in our start, asks the PIC microcontroller to output values at port B, which should display a value 6 on our 7-segment display, like you guys saw. So that's what basically our start is going to do. So once our start is executing, as in it has displayed the value 6 already, and an interrupt occur, let's get back right now to our interrupt section. As you can see, this is an interrupt section. Okay, now interrupt section right now originates from the memory location 04. That's where interrupt registers start their execution. And the interrupt here right now, you can see a certain label display, and we saw already how to do creation of labels. This label right now will permit us to do looping in our interrupt. So basically the next instruction will ask a display of 0 on our 7 segment display, whereby that's done by calculations. And I think in our previous video the calculations have been indicated already, so just try to follow the other videos and you get track on this other video too. And here we can see a certain loop 1. This loop 1 here permits us to create a delay of 0.5 seconds, like I said already. As you can see, it's decrementing count 1 and count 2. So once 0 is displayed on the 7 segment display, it's going to stay for 0.5 seconds. And again, right now here, we're going to have 2. It's going to stay for 0.5 seconds. And the next one follows right now. We're going to have 3. It's going to stay for 0.5 seconds. No, sorry. 6 is going to stay for 0.5 seconds. And so on and so forth. So right now we'll proceed. After it has displayed all of those numbers, you can see right now the final instruction here, return from interrupt enable. So once it has executed an interrupt in the interrupt register, it returns from the interrupt. So you guys might be like, what's really happening? Because our own case, it counted from 0 right up to 8, right? Yeah, that was so because what we have our go to display. So that was somehow a looping function. That's why it was counting as in 0 to 8 after it takes back 0 to 8. And this return from interrupt was not that respected because we didn't ignore the part of go to display. So you can try modify the code wherever you are to obtain a different functionality. Guess that's all for our video, for the coding part right now. So let me get to explain the security part and we will do the simulation. Okay, like I was saying right now, as you can see here, our switch is connected to a power supply that you can see 5 volt, and it is also connected to the ground. So actually what's an interrupt is an event that must be acknowledged by peak. So for an interrupt to be triggered, right, something must be like changed. Yeah, and this change is caused by change in state of this switch. This switch can either be a high or a low. Once it changes state from low to high, an interrupt is being triggered into a RB0, and when an interrupt is being triggered right now, it's going to correspond exactly according to our 7-segment display. So basically that's all about the connections. In our previous video we saw that the 7-segment display were connected to the pins 0 to 6, but here right now they are connected to the pins 1 to 7. So while doing your calculations, please take note of the difference. Don't just to maybe cram up a little bit. And you must make sure too that your cathode 7-segment display is connected to the ground. Yeah, and that's all for the video. We will do the simulation for surety. As we have been seeing in our previous video already how to upload a code to a peak. Let's just re-upload for assurance. Okay, so desktop, you go to where you saved your work. Where you save your work right now, you are going to see a hex file, and that's actually what you are uploading into your peak. From there you are going to say okay, and we do the simulation. So you see actually what's happening is that the 7-segment display for now is displaying 6, right? Yeah, you can see the 6. So this is what the peak is busy doing, displaying 6 on the 7-segment display. But once an interrupt occurs, that's a change in state from low to high occur. That's why interrupt is being triggered, and when an interrupt is being triggered, it executes what the interrupt is asking him to do. That's count from 0 to 8. Once it has reached 8, it recounts again according to our looping. Yeah, that's why it actually counts 0 to 8 and 0 to 8 and 0 to 8. So thanks you guys for watching. Thanks you guys for finishing the video up to the end. Make sure you subscribe to the channel so that you follow and keep track to the next video upcoming. As you guys know, we're going to look at the third interrupt part 3. Yeah, maybe before tomorrow. So thank you guys very much for watching. Keep track to the channel.